How can a pure sample of barium sulfate be obtained from barium carbonate? This looks like a difficult question, but you have to realize that a test for sulfate is actually just to add barium chloride aqueous, which is soluble, in any sulfate, and it'll form barium sulfate, which is a solid. It does not dissolve, which is a white precipitate, right? And if you dilute it in hydrochloric acid, it's going to form, barium carbonate is going to form barium chloride, and it's going to be soluble. And you add dilute sulfuric acid, and it's going to form barium sulfate, so it's a solid now. Filter and crystallize, you don't need to. But in the second statement, it says filter and wash, because you filter it out, you have it, and you just wash it to clean it, and you have barium sulfate, right? That's the idea. So the correct answer is B. Let's take a look at why C and D are wrong. Dissolve it in water, so it won't dissolve because it's a carbonate. And well, crystallization. Again, dissolve. This is where there. It won't dissolve. All barium carbonates, all carbonates are insoluble, so you can't dissolve them, right? But all barium salts are also insoluble, aside from barium chloride. The answer is B. Which statement shows that graphite and diamond are different forms of the same element of carbon? So they're allotropes, right? Carbon, the element carbon, can exist in two forms just by having its bonds be arranged differently. Graphite, it'll make 3 bonds with 1 free electron. With carbon, it's going to make 4 bonds, right? Both are giant molecular structures. Both graphite and diamond have giant molecular structures. And that's true, but that doesn't tell us if they're all made up of carbon, right? It could be silicon dioxide for all we care. Complete combustion of equal masses of graphite and diamond produces equal masses of carbon dioxide and no other products. That makes sense to me, because if you burn diamond of, let's say, 12 grams and in excess oxygen, and it gives you 1 mole of carbon dioxide, you know this had 1 mole of carbon, right? And similarly, if you had graphite at 12 grams, I say grams because we don't know if it's made of carbon, so I can't count the moles. So if this was 12 grams and I only got carbon dioxide, which was also 1 mole, I would be confident that this is all carbon as well, right? So that's the best way to figure it out. And that's something you can actually do in a lab. That's how they actually found out they were the same. So our correct answer is B. B, right? That's the interesting B. Okay. Graphite and diamond have different melting points. Sure. So does silicon dioxide and diamond, I guess. How would we know if both are made up of carbon only? Graphite, well, yeah, that's just fact, but doesn't mean it's related to our answer. Copper wire is used to complete an electrical circuit, more of a physics question apparently. What happens to the copper wire? Electrons move along the wire to the negative terminal. Positive ion stay in position. Okay. That's how conduction works, but in actuality, electrons will move from the negative terminal and go to the positive terminal. So electrons move along the wire to the positive terminal, positive ions move to the negative. The ions themselves don't move, it's just the electrons that are free to move. Electrons move along the wire to the positive terminal, positive ions stay in position. I think we have our answer. And I'm sure the last statement is just another iteration. Let's move on. I think we got it. The answer is C. Very tricky question for, I think, any novice O-level student. Which use of for sulfuric acid are correct. As a bleach in the manufacturing of wood pulp for paper, as food preservative in tinned foods, as raw material in the manufacturing of detergents, as fertilizers. So you end up using sulfur dioxide in actuality for the first two, right? That's where they're used. And as raw material, that's actually correct. You use a bit of sulfuric acid. And as fertilizer, you end up making sulfates from sulfur dioxide or sulfur trioxide, which is used as fertilizer, right? So the correct answer is D only. D. Two isotopes of chlorine are 35, chlorine 35, and chlorine 37. Using these isotopes, how many different relative molecular masses are possible for the compound with molecular formula C2H3Cl? Wow, look at this question. Okay, what could happen is, let's just think of a compound that has, 3 chlorines. So this part is going to be constant, right? This will have an MR of like 12 times 24, 5, 6, 7. This is going to be 27. Any difference in, molecular mass is just going to be because of chlorine, right? So it has 3 chlorines, and it's a permutation thing. So this is my first chlorine, this is my second chlorine, this is my third chlorine. Now this is gonna get tricky real soon. Let's see if we can figure it out. Okay, the first case is all 3 could be 35. At least 1 could be 35 or 37. At least 2 can be 37. And doesn't matter which order, 37, sorry. And all of them can be 37. I think we have it sorted. We can figure it out. So what the total MR is. But I don't think you'll get any other combination. So that's 1, 2, 3, 4. You have 4 possibilities over here. The correct answer is C. The pH of an aqueous solution of hydrochloric acid is 2. What will be the pH of the acid after addition of 10 grams of sodium chloride? Sodium chloride is neutral, so it won't react with the acid, so it won't change the acidity at all. And because it's not water being added, you're not adding water, so you're not diluting the acid either. So the acidity is going to be 2. Answer is B. How many moles of hydrogen chloride are formed when 1 mole of methane reacts with a large excess of chlorine in sunlight? So they're talking about the substitution reaction that happens with alkanes and chlorine. Substitution, right? So what happens is a methane molecule will have, 4 hydrogens, and it will react with a chlorine molecule to form okay, and well, it's going to be HCl, right? It's going to form that. Let's just put a plus in there, right? Now this reaction could happen multiple times. This same molecule can react with more chlorine if there's more chlorine around, and each of these can be replaced. So each time I replace, let's say, these badly drawn hydrogens, what's happening is I'm producing 1 more HCl, right? So there was already 1, I produced 1 more. Let's actually write them down, right? Okay. another HCl. Then what you do is this thing reacts again with another chlorine, and that hydrogen will form another HCl until it's all gone. Final fluorine, and then you have HCl. So you made 4 HCl's molecules from one molecule of this. Now I've written mole over here, short for molecule, but we can say the same thing as for 1 mole. So if you have 1 mole of methane, if this is 1 mole, you'll end up producing 4 moles of HCl. And the correct answer is 4, which is delta D. Which statement about alcohols are correct? All alcohols contain the hydroxide ion OH. Well, they have the OH over here, but it's not the hydroxide ion. It doesn't behave as an ion. It doesn't just split when you throw it in water and turn into this. One good indicator, if you're like ever so slightly confused, is what things have OH ions, right? OH negative ions, hydroxide ions. What things have them? Alkalis have them, and they're alkaline, right? Are alcohols alkaline? Not at all. So they don't produce OH ions. So it's wrong for us to think that they have hydroxide ions. Even though there's an OH here, it just doesn't behave like an hydroxide ion. Ethanol can be formed from ethene using the reaction catalyzed by yeast. I think they're trying to talk about something else, which is fermentation, right? They're trying to talk about that. So from simple sugars using yeast, you can produce ethanol. Methanol can be oxidized to methanoic acid. I see why not. All alcohols can be oxidized to their counterpart acids. Well, maybe not all, but that's an A-level thing. Methanol definitely can turn into methanoic acid. The alcohol X and Y are isomers. Well, 4 carbons, do they have the same molecular formula? They look different, certainly. The OH is, one has it in the corner. This is, in the second carbon. What's their formula? I think it's going to be the same because it's the same thing. C4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogens and 1 oxygen. And this is also C4H10O. So they're isomers because their molecular formula are identical, but they're structurally they're different. So 3 and 4 is the correct. God. Okay. 3 and 4. The answer is D. Ethene is a covalent compound with a simple molecular structure. Which statement about ethene is correct? Ethene is liquid at room temperature and pressure. It's a gas. Liquid ethene conducts electricity. Why would it? It's a simple molecular structure, not ionic, right? Well, and by that I mean molten, not liquid. Same thing. One ethene molecule contains 16 protons. Does it? Carbon has 6 protons. Hydrogen has 1. You have 2 carbons and you have 4 hydrogens. That's 12. You have 4, a total of 16. Yeah, that's true. The total number of shared pairs of electrons in ethene is 5, and that's probably like 1 too many. Ethene has a double bond, so that's... Shouldn't that have an even number of electrons? Okay, they're counting the pairs, right? So we can see each line is a shared pair, and it has 6 paired electrons, right? So C is our answer. Compound P is the only substance formed when 2 volumes of ammonia gas reacts with 1 volume of carbon dioxide gas, both volumes are RTP. What is the formula of P? So in volume parts, so essentially what's happening, you can convert them into moles. 2 ammonia molecules are reacting with 1 carbon dioxide molecule to form 1 molecule, which is P. Now P should have, because it's the combination of these things, it should have the same number of carbons, oxygens, hydrogens, and nitrogens as there are on the left-hand side. The left-hand side has nitrogens, hydrogens, carbons, and oxygens at the quantity of 2 nitrogens, 6 hydrogens, 1 carbon, and 2 oxygens. So we have to figure out which of these have that. So the first one looks like it does. It does have that, right? That's 1 carbon, 2 oxygens. I see 2 oxygens, I see 6 hydrogens, and 2 nitrogens. What do you know? This is P. Wow. Let's rule the rest out. 1 oxygen, that's not it. It needs to have 2 oxygens exactly. Okay. This has 8 hydrogens. That's wrong. It's too many hydrogens. And the last one also has 8 hydrogens and 3 oxygens. That's trying to have a party on its own. Party, right? And the answer is A. Very easy question. Oil floats on water. Which statement is not true for oil and water? Oil and water are immiscible. I mean, that's why it floats on it rather than mixes with it. So this is true. Oil is less dense, that's why it floats on top of it. Oil is on top of water because it's less dense. Some molecules of oil have a higher relative molecular mass than water. Oil is a mixture of different, compounds and like longer chains and short chains, and that is true, right? That's kind of true. But if you have your doubts, let's put this on hold, right? Let's not lock it in. The type of bonding within water molecules is different from type of bonding within molecules in oil. That is false because they both have covalent bonding, right? That's definitely false, and that's our answer. And option C is more likely to be correct if you're thinking about that. How many of the structures show an unsaturated hydrocarbon? So for an unsaturated hydrocarbon, we have to identify our carbon-carbon double bond, right? So, well, here you go. Unsaturated, that's 1. That's 2. This is not unsaturated. This is just an acid because it's not a carbon over here. This is not it. And this is definitely not it. And doesn't even have a double bond. So the correct answer is B. The graph gives the melting point of a mixture of lead and tin. So this is interesting. Percentage tin in the mixture. So if you have 0% tin, is the melting point of lead. And if you have 100% tin, is just the pure melting point of tin. That means it's just all tin, right? Or it's all lead. And what's interesting is that as you add tin to it in the same ratio, the melting point will decrease, and it actually goes down. You'd expect the melting point to kind of go like that, rather like a straight line like that, but it actually goes way at the bottom at this ratio, which is like 75 or 60 or 70. I think it's more 70. It has the least melting point. Then it starts climbing up when you have more tin. The graph shows that any mixture of lead and tin must have a melting point that is above that of tin. Below, any mixture will have a melting point. Well, it can have above and below that of tin, right? So A is out. Below that of lead, it has to be below that of lead. So any boiling point you're looking at is all below that of lead, right? So that's correct. Below that of both lead and tin, no, that's incorrect because over here it's rising. So this is more of a graph question rather than anything else. And between that of tin and lead, Well, between would be somewhere if that was our graph, right? That's not our graph. So below, it has to be lower than leads. So the correct answer is B. In an experiment, 1 centimeter of gaseous hydrocarbon Z requires 4 centimeter cube of oxygen for complete combustion to give 3 centimeter cube of carbon dioxide. All gases volume are measured at RTP. So we just have to do the math over here. So for the first one, for A, I think we can have a good idea that Z should have 3 carbon atoms because it's giving us 3 centimeter of carbon. So some things I don't even want to bother looking at, like A will give me 2 centimeter cube of carbon and B will also give me 2 centimeter cube of carbon. So it's between C and D. So let's figure out between C and D. So we simplified our problem by a lot. Didn't want to write down 4 equations. Let's do C3H4 reacting with oxygen to give us, that's going to be 3 carbons and some H2O. And to balance it out, we're getting 3 over here, and this has to be 2. So this is 6 over here and 2 over here. So 4, right? 4. Yeah, 8 over here, so we need 4. So that's our answer. C is our answer. And let's just take a closer look at D as well. It's C3H8, which will produce 3 CO2s and 4 H2Os. And you have 6 oxygens over here and 4 over here, and you'll need 5 O2s to do that, right? So the correct answer is C. The diagram shows the apparatus used to extract aluminum from aluminum oxide. Yeah, here are electrodes, carbon electrodes. Okay, which statement about the process is correct? The electrolyte is a solid mixture of aluminum oxide and cryolite. Well, it's not solid. It's not solid, it's molten. Right? How would it mix? The electrolyte is aluminum oxide dissolved in, no, it's molten aluminum oxide and cryolite. The equation for the reaction at the positive electrode is, this is actually at the cathode at the negative electrode, because it's gaining electrons, right? The cathode gives electrons. The positive carbon electrode loses mass during the process and needs regular replacement. That's actually true, because in the high heat and oxygen is produced, it burns, carbon burns, reacts with oxygen, and eventually loses mass. So D is the correct answer. A student has 5 reagents: hydrochloric acid, sulfuric acid, nitric acid. Then on the other side you have 2 carbonates, calcium and copper. How many soluble salts can be prepared? So essentially you have to understand that they're taking these 2 compounds and mixing it with the acids. So the carbonate doesn't really matter. What you have is calcium ion on one side and the copper ion on the other side, and they're being mixed with the chloride ion, the sulfate ion, and the last one is the nitrate ion, right? And they'll be making a few interesting things. Let us see. Okay, so it's gonna make calcium chloride, calcium sulfate, and calcium nitrate, right? On the bottom side is going to make copper chloride, of course, CuSO4, my favorite, and copper nitrate, right? Now all of these are soluble except calcium sulfate, which is sparingly soluble, right? Everything else is more or less soluble. All nitrates are soluble, right? Calcium chloride is soluble, copper chloride, copper sulfate we know soluble. So we have a count of 5 soluble salts. So the answer is C. Aqueous copper sulfate solution is placed in an iron container and left to stand for several days. So something interesting is going to happen. So you essentially have iron with copper sulfate. And will this reaction essentially take place? Iron is more reactive than copper and will react. So it's going to displace it. You're going to end up producing copper metal and iron sulfate, right? So let's figure out. Atmospheric oxygen reacts with the copper. Okay. Okay. Some fine iron particles are formed in the solution. They won't be iron particles because the iron will be dissolved in sulfate form. Let's just write that down. Going to be iron sulfate, or FeSO4, right? It's going to be dissolved. The part of the container in contact with the solution is coated with copper. That's going to be true. That is true. The solution turns from green to blue. That's actually the other way around. It's going to start being blue because this is blue, and this is going to start giving you a green tinge. Right? So it's the other way around. C is our answer. Which substance will ethene react to form more than one product? So argon it's inert, it won't react. There will be no reaction. Ethene can react with hydrogen to give you only ethane, nothing else. Right? Now oxygen is interesting because it can only burn with oxygen, just oxygen, right? It's going to react this way, and with oxygen it's going to turn into carbon dioxide, or it could give you carbon monoxide as well, right? So oxygen can give you, interestingly enough, another thing. And the last one, it'll give you ethanol. The last one will give you ethanol. So C is our answer.